So hi all, in this video we're going to see about point, line and circle attributes, which are the basics in computer graphics and OpenGL of unit 1. Let's move on to the topic. So first, pixel and points. We are going to see what is pixel and what is point. Computer graphic at its simple, draw a point somewhere on the screen and make it specific color. Building on this simple concept to produce lines, polygons, circles and other shapes and graphics. In OpenGL, we are not concerned with physical screen coordinates and pixels, but rather positional coordinates in a viewing volume. OpenGL worries about how to get your points, lines, etc. projected from your established 3D space to a 2D image on a screen. So this is the viewing volume. It is going to consist of an area enclosed with a Cartesian coordinate space that ranges from -100 to +100 on all the three axes. So this is the y-axis, this is the x-axis and this is the z-axis. It is going to consider 100 in all the three axes in both the directions. So we call this volume with a call to GL ortho. So this is the specific calling command in GL ortho. So a 3D point, the vertex. So function GL vertex, one of the most used function in all the OpenGL API. The lowest common denominator of all the OpenGL primitives is a single point in space. The GL vertex function can take from one a pointer to 4 parameters of any numerical type from bytes to doubles subject to the naming conversions. So this is the diagrammatic representation of that one. So primitives, is this vertex a point that should be plotted, or it is the endpoint of a line or the corner of a cube? The geometric definition of a vertex is not just a point in space, but rather the point at which intersection of two lines or curve occur. This is the essence of primitives. A primitive is simply the interpretation of a set or list of vertices into some shape drawn on the screen. There are 10 primitives in OpenGL, from a simple point drawn in space to a closed polygon of any number of sides. So drawing points, one way to draw primitive is used to glBegin command to tell OpenGL to begin interpreting a list of vertices as a particular primitive. You then end the list of vertices for the primitive with glEnd command. glBegin glPoints tells OpenGL that the succeeding vertices are to be interpreted and drawn as points. For example, glClear, glColor, buffer bit. So this is which is similar to the clear screen command, which we will be using in C program. Then glBegin and glEnd. So inside this glBegin and glEnd, we are going to give the vertices. See, vertices which is going to be in 3 dimensions. So that's why it is represented as 3f here. So first point, second point and third point. So it will be going to be in 3 dimension. So 3 points. Okay. So this is the representation of drawing points in the OpenGL. Next, sine or cos theta, a circle drawn in the xy plane and a line segment from the origin 0 to 0 to any point on the circle makes an angle A with the axis. For any given angle, the trigonometric functions sine and cosine return the x and y values of a point to the circle. By stepping a variable that represents the angle all the way around the origin, we can calculate all the points on the circle. The C runtime functions sine and cos accept angle values measured in radius instead of degrees. There are 2 into pi radians in a circle. So drawing a circle, it is going to calculate the x and y coordinates for an angle that spins between 0 degree and 30 degree. So this is expressed programmatically in radians rather than degrees. So setting the point size, when you draw a single point, the size of the point is 1 pixel by default. Changes the size with the function glPointSize. We are going to give the point size inside the C bracket. It specifies the approximate diameter in pixels of the point drawn. So you can note down here. So not all the point sizes are supported, however, and you should make sure that point size which you specify is available. So GL point size must be called outside the GL begin or GL end statements using a point size larger supported. OpenGL uses the largest available point size but does not keep growing. The range are clamped to the range. Larger point sizes are represented simply by larger cubes. This is the default behavior, but it typically is undesirable for many applications. Need anti-aliasing, a technique used to smooth out jagged edges and round out corners. Thank you.